This video focuses on factorising equations. All you need to do to be able to factorise is to be able to find the highest common factor, whether that be a number or whether that be a letter value with algebraic equations. Factorising is essentially the opposite of expanding equations. So we have an equation, we want to look for the highest common factor between the two terms we have here, so 5x and 30, and we want to put that back into an equation with brackets. So the opposite of expanding an equation. If we look at 5x and 30, the highest common factor between those two is 5, because you can divide 5x by 5, giving you just x by itself, and you can divide 30 by 5, giving you positive 6. So that is our answer, just working the complete opposite direction. So same thing applies to the second equation. Looking for the highest common factor between the two terms to factorise it. So in this case, the highest common factor between 12p, that's essentially, we can write this one out just so you can see what I mean, 12 times p, that's essentially what it is. So the highest common factor between these two, yet again, we're going to be able to get p on its own because the highest common factor is 12. You can divide 12p by 12. 12p divided by 12 is going to give you p on its own. And negative 36 divided by 12 is going to give you negative 3. Sometimes the highest common factor won't just be a number on its own, and it won't always be a positive number outside the brackets as well. So you just need to look carefully for the highest common factor. So let's take a look at this first equation, for example. I'll put the brackets in ready to go for both of them. So let's look at these two terms. We have negative 7p squared and negative 14p. So you know that 7 is a factor of both 7 and 14, but obviously it's negative in this case. So we can actually divide both of these terms by negative 7 and negative 7, but you should notice that you can also divide both of these terms by p. So the highest common factor in this case is negative 7p. So that's what's going to go outside the brackets. Divide negative 7 by negative 7, you get 1. P squared divided by p. Index laws leaves you with p to the power of 1, which is just p by itself. In this case, negative 14 divided by negative 7, that's a negative divided by a negative, which gives us a positive. So positive 2. In this case, the p's cancel each other out because of it is equal to 1. So there is your answer. Negative 7p, and then in brackets, p plus 2. It would have been okay also to have in this case, another answer that would have been acceptable could have been this. You actually could have said the highest common factor was 7p, and then you could have flipped the signs of everything inside the bracket. So it would have ended up with negative p take 2. That would have also been acceptable, but I prefer the first way, taking out the highest common factor and taking the negative out of the brackets. Okay, let's look at the second equation. So look at both terms, and we're trying to find yet again the highest common factor. So you can see there's an x in both, so x is going to be a factor of both of them. So we're looking for highest common factor between 8 and 20. You can divide both of those by 4 at the highest. And x is a factor of both of them. So 4x is our highest common factor, goes outside the brackets, so we need to then divide both terms. 8 divided by 4 is 2, and x cubed divided by x, subtraction in the laws of indexes or indices, is going to leave us with x squared. So it's going to be 2x squared, and then 20 divided by 4 is going to be equal to positive 5, and then x will cancel out. So as you can see with both of these ones, sometimes the highest common factor will have an pronumeral as well as a number. Sometimes it might not be a positive, it might be a negative as well.